Okay, good morning Year 12, single mathematicians. So just back with 10.5 connected particles again, but some lift questions, slightly different to the ones we did last time. So there's not many lift question examples in the textbook, but they do come up in the real exams, so we may as well go through them in detail. So e.g. number 1, we've got a light scale pan is attached to a vertical light inextensible string. The scale pan carries two masses A and B, as shown in the diagram. The scale pan is raised vertically using the string with acceleration 0.5 meters per second squared. And we've got to find a few different things: the tension in the string, the force exerted on mass B by mass A, and find the force exerted on mass B by the scale pan. So I'm just going to draw this diagram again, but slightly bigger. So object B is actually 600 grams. Now all of the equations that you should know require kilograms. So the first thing I'm going to do is write that 0.6 kilograms. And object A is 0.4 kilograms. It's accelerating upwards, given in the question, 0.5 meters per second squared. Okay, find the tension in the string. So, okay, light scale pan is given in the question, so the mass of the pan itself is negligible, so we ignore it. For everything else we take into account. So for this first one, I'm going to treat this as one entire object. So I'm going to resolve for part A the entire object. So the scale pan and its contents, everything. Now, if you could think about the forces acting on the entire scale pan and its contents, it's attached to a string, so there's going to be a tension. And this scale pan now and its contents has a weight, and that weight would be 1 kilogram, so 1 newtons, and that's it. So I'm treating this as a single object now. Don't have to worry about reaction forces or anything inside. They'd all cancel out with each other. So it's just T newtons there, 1 coming down for the weight. Right. Okay, in this direction, is the object accelerating? Yes. So you should state Newton's second law. F equals ma. The mass of this entire object and its contents is 1 kilogram. The acceleration is 0.5. The resultant force, the other way to work it out, is the forces going with the motion, T, tension, subtract the forces resisting the motion, which is the weight, 1 And if you make T the subject, you'd have 0.5 plus 9.8. Remember, G is 9.8 to give you 10.3 newtons, and that's it. Okay, for part A. This is where it gets a little bit more confusing, though, a bit more technical. I need to really understand the physics of what's going on. So, find the force exerted on mass B by mass A. That is a reaction force. So if we look at what it says again, exerted on mass B by mass A, Now, this force would be exactly the same as the force exerted on mass A by mass B. Okay, so remember Newton's third law is equal and opposite. So the force exerted on mass B by mass A is the same as mass A by mass B. So I'm going to just take into account the one which, like the simpler object, which for me is object A, and consider the forces acting on object A and object A only. So object A, so I'm going to do part B, resolve object A only. Okay, so object A has a weight 0.4 g newtons. Object A is in contact with a surface. There's going to be a reaction force, Ra newtons. And there are no other forces acting on object A. Those are the only two. But remember, this object is accelerating. So F equals ma. Mass of object A is 0.4. Acceleration of object A is 0.5. And now the resultant force is the force going with the motion. Subtract the forces resisting it. So Ra subtract 0.4 g. And if you make Ra the subject, you would do 0.4 times 0.5 plus 0.4 times 9.8, which is 4.12 newtons. And that is the force that B exerts on A, which is exactly the same as the forces A exerts on B. Right, part C. Find the force exerted on mass B by the scale pan. Now, there's not much choice with this. We have to just consider resolving B only. Force is acting on object B. Now, object B has a weight. .6 g newtons. Object B is in contact with a surface, so there's going to be a reaction force. Call that RB. That's the thing we want to work out. But object B is also in contact with another object, which is A. If you remember, we just worked out the force exerted on B by A, and by Newton's third law, that force, which was 4.12 newtons, that'll be exerted on B by A. So there's going to be a reaction force going in the other direction, and this one's 4.12 newtons. And those forces labelled in green are the only forces acting on object B. And remember, object B is accelerating. F equals ma. Mass of object B, 0.6. Acceleration of object B, 0.5. Resultant force would be forces going with the motion, so it just looks like it's RB. Subtract the forces going against the motion, these two. 4.12 subtract 0.6 g. And if you make RB the subject, 0.6 times 0.5 plus 0.6 times 9.8 plus 4.12 to give you 10.3 newtons. Now, that's not easy, to say the least. So that's the most technical stuff we've done so far in terms of forces and the physics and everything. But again, in part A, we're allowed to consider the entire system as one thing to work out the tension. And then in part B and part C, we had to consider single objects, object A separately, then object B separately. And then that was it. Now, in terms of what you can try, so if you find page 171, it's exercise 10E, and we're looking for lift questions. So question 4 would be useful. And that's the only lift question actually in that exercise. Just have a look if there's anything in the mixed exercise. Okay, there's a page 177, question 2 in the mixed exercise. That's a lift question, and I believe that is it. Yeah, so if you try those 2 questions, and if you get any problems with either of them, post a message on the Teams chat and I'll do a video to try and help you out.